All right, so for this one, it's kind of a conceptual question. It's asking what is the frictional force that's holding the block in place. So we have a block that's on a vertical wall, and there is a force that's being applied. So FA is the force that's being applied. So when we think of this, if we do a free body diagram, we have a force that's being applied that's holding that in place. So the block is not in motion, okay? And it's not going through the wall. So what we're going to do is we're going to look at the x components and the y components, okay? So then what does that mean? Well, that means there is a normal force, right? There is a normal force that's being exerted that's balanced. It's equal and opposite of the force that's being. So the net force in the x direction is equal to 0. So if we talk about, because this is positive and this would be a negative force. Now we also know that gravity pulls down in the negative direction, and that's just the mass times the acceleration due to gravity, right? We know that. Well, since it's not moving up or down, there has to be an equal and opposite force that's moving up. Now, what is that? Well, that's friction force. That's the frictional force. So we have a frictional force that's holding it in place. Well, what is that equal to? Well, it has to be equal to, well, think of it like this. The block isn't moving up or down, so the force in the y direction also equals 0, because it's literally not moving. So that has to be the opposite of gravity. So the short answer is that the frictional force being exerted on the block is equal to the mass of the block times the positive value for g. That's it. So the free body diagrams are really helpful. And then if a block isn't moving, right, then we know the sum of the forces in the x direction have to be 0, and the sum of the forces in the y direction have to be 0 because it's not moving. And then you just kind of go through and say, well, what all forces are being applied, right? And also, for every force, there's an equal and opposite force, usually, sometimes, especially if it's sitting still, right? In other words, if there's a force being applied in one direction and it's not moving, there has to be another force that's equal and opposite. So there's that. So the short answer is this right here.